All right, here we're going to start our notes and our learning in Chapter 7. So in this chapter, we're really going to be looking at polynomials. First, we're going to be adding and subtracting them. Then we're really going to be looking at multiplying. And then the real reason we're looking at polynomials is because these are going to lead into our quadratics, which we're going to spend a lot of time on to wrap up this semester. So the first thing you'll see is we always start with our learning targets, but I changed our learning targets a little bit. So now you'll see I have this little tab that you can make with your little learning target sheet. So you're going to fold along the middle line here and then glue it on each side. And you'll see our learning targets are right on the back. I did this just, I borrowed this idea just so we can keep things organized so you can quickly find where all of your information is. So really today we're going to look at these top two learning targets. Is I can name polynomials and determine this should say degree. And then I can add and subtract polynomials. We're going to look at both of those two things. So the first thing we have to figure out is what is a polynomial. Okay, so we're going to do some vocab, and this is going to be really specific vocab today. So make sure that you have everything that we're going to need. Okay, so a polynomial is, I'm going to read us the definition from the book, and then we're going to kind of put it in our own words. So a polynomial is a monomial or sum of monomials. Each monomial is called a term of the polynomial. So a polynomial is made up of several terms. Okay, that's just kind of how we're going to say it. Several terms, and these are, we're going to call them monomials. Right, mono means one. So let's give some examples and some characteristics. That's where we're really going to be focusing. So here is an example, and we're going to take several notes up here because there are some terms and some keywords that we absolutely need to know. So if I have 3x cubed minus 2x squared plus 4x minus 1, that's just our kind of example. So now we're going to look at the different parts of this. The first thing we want to notice is that this is written in standard form. Okay, so this is standard form. So what standard form means is that my variables and my exponents go in decreasing order. So I start with the largest exponent and I continue to get smaller and smaller until I don't have any exponents anymore. That's what standard form means. Another thing is we have to look at this value here that does not have an exponent. Okay, and I'm going to get my pens out to take some actual serious notes here. Okay, so this purple thing, this thing at the end, this is called the constant term. And I'm going to let myself know that there's no variable. So the constant is just the number that's all by itself. Okay, so when we're written in standard form, we have this leading term, right, our first term. This number with it is called our leading coefficient. So you're like, what's a coefficient? Well, let's give ourselves a little definition of what a coefficient is. So a coefficient is the number in front of the variable. Okay, so 3 would be a coefficient, -2 is a coefficient, 4 is a coefficient. But when we're dealing with polynomials, generally we want the leading coefficient, which means the number with the biggest exponent. So then the other thing that we really care about and want to know is also dealing with that leading term, that first term. And that's the degree. This would tell us the degree. So again, I have to be in standard form, so my exponents go in order from biggest to smallest. And then that first one with the biggest exponent, that exponent tells us the degree of the polynomial. And then that's also our leading coefficient. So this polynomial here has a degree of 3, and there are 4 different terms, right? There's 1, 2, 3, 4. So that's one way I could name this polynomial, is that it is 4 terms with a degree of 3. Okay, so keep that in mind. We're going to start using these words a lot. And then our constant term is always going to be that thing with no variable. Okay, so let's give ourselves some more examples. Really here I want to look at some non-examples because the examples are fairly easy to come up with. It's the non-examples. So things that are not examples is if I have a variable in the denominator. Something, if I end up with a variable in the denominator, that means it is not a polynomial. If I have a radical, that is not part of our polynomial. If I have a non-positive exponent, that is not part of a polynomial. Okay? So these are just a couple of things that we need to know when we're dealing with polynomials. So if at any point you see any of these real three things, that tells us it's not a polynomial. Polynomials can be really simple. It can be something simple like 5 minus x. It can be something big and complex like our other example over here. It can be a mixture of those two things, but it cannot include any of these non-examples. That's kind of our big step. Okay, so what you are going to do now, oh no, that one broke, is we're going to glue this in. So we have our kind of our vocab and just our key terms that we're really working on here. And then we're going to use this, and you're going to color or shade. What would be really awesome is if you shaded several of them. This page right here, it says polynomial or not. Okay, so that's what we're going to glue in next. This is how we're going to determine, just based on that information we just looked at, if some of these are polynomials or not. And I'm only going to do a couple of them for you, and then you're going to spend a little bit of time going through and doing the rest of them. So here are your instructions. So shade each polynomial. So if it's not a polynomial, explain why. So I'm just going to look at this top row, and they're not in order like that. So you're going to have to go through and tell me which ones are polynomials and which ones are not polynomials. So in this first one, I see that this is a polynomial. It's not written in standard form, but it is a polynomial because I've just got different terms with just positive exponents, and I continue on. Okay? So this, I notice, is not a polynomial. This I have a funky exponent. Okay? So here I would explain why this one is not shaded and why it's not a polynomial. This is not a polynomial because I have a fraction exponent. Okay? So that's why that one's not a polynomial. So now you're going to take a little bit of time and go through all of these and determine, are they polynomials or not? And if you ever have a question about that, just let me know and I'd be happy to walk you through it. The other learning target today that we're really going to be looking at is adding and subtracting these polynomials. And here again is somewhere where you're going to need a little bit of color in your notes. So go ahead and get that if you've got it ready. Okay? So the first thing we need to know is that these problems can be written in different ways. We can see f of x, remember our function notation, f of x plus g of x. We can also see them written this way as f plus g of x, or we can see words, find the sum. All three of those things mean we're adding. And similar with subtracting, that we can show it this way, subtracting. We can see the subtracting in our parentheses, or we can find the difference. So here we're given three different polynomials. Okay? And we notice that they're all polynomials because they all have those positive exponents. Even though the numbers in front of them are negative, that's okay. We're just looking at our positive exponents. So let's do this one together. Find f of x minus h of x. So when we're adding or subtracting those polynomials, we have to keep track of their names. That's just the different letters in front of them. And then what we're doing to them. So here we're told to subtract f of x and h of x. But take h of x from f of x. So my f of x goes first. So I've got 9x squared minus 4x plus 2. And then I'm subtracting. And when I'm subtracting, I absolutely need to use parentheses. Negative 2x squared plus 3x minus 10. So when I'm subtracting, I use these parentheses in order to distribute this negative sign, because I'm subtracting each piece from above. Okay? So I'm going to go ahead and distribute this negative sign. So I end up with 9x squared minus 4x plus 2. Nothing changes from my first one. Negative times a negative is a positive. Negative times a positive is a negative. And negative times a negative is a positive. So now I can see I've got a bunch of different terms here. So now I'm going to combine my like terms. So I see these two have a squared term, so I can combine them. So 9, 10, 11x squared. These ones just have a regular x. Negative 4 minus 3 is minus 7x. And then these are my constant terms, so 2 plus 10 is 12. So I've subtracted these. Even though pieces of it got bigger, this is how we're going to subtract those polynomials. Okay? And it's really important to, when you put your final answer, to put that in standard form as well. So your largest exponent, and then your going down exponents, and then your constant term at the very end. Okay? So now let's look at the second example. So find the sum of f of x and g of x. Well, so f of x was 9x squared minus 4x plus 2 plus, and I'm adding to it g of x, which was 3x minus 1. When I'm adding, I still use parentheses as my first step, just to make sure that I have everything that I need. And now I see that I'm just adding. So when I'm adding, I can just get rid of my parentheses. So I have 9x squared minus 4x plus 2 plus 3x minus 1. And again, I find my terms. There's the only one with an x squared, so I've got 9x squared. Then I have some terms with an x, so a negative 4 plus 3 is negative x. And then I've got my constants, so 2 minus 1 is 1. So again, my final answer is written in standard form with my largest exponent first, and then continuing down. Okay, so now let's look at this last one, and I want to show you a different way to subtract. And it doesn't matter to me which way you do it, horizontally or vertically. Either way works. So here we're going to find f minus g of x. So my f of x was that 9x squared minus 4x plus 2. And I'm subtracting my g of x, which is 3x minus 1. And again, we always use our parentheses. Okay? So now I can subtract going vertically as well, which is kind of my preference. So I see I have a positive 2 minus a negative 1, which ends up getting me a positive 3. Because when I'm subtracting a negative, I change the sign. Now I see I have a negative 4x minus 3x, so that gives me a negative 7x. And I have 9x squared minus nothing, so I have that 9x squared. So my answer is still written in standard form. So one thing I want you to note is you can add them going this way as well, add them vertically. It doesn't matter. The biggest thing is to make sure that your terms are lined up. So here I lined up my constant terms, I lined up my terms with an x, and then I would line up my terms with an x squared, and then my cubed, and then my quartic, and continue on and on. So just make sure that they're in line if you're going to add or subtract them vertically. So now that we've gone through and actually classified if we're talking about polynomials or not, and we've actually looked at several examples of adding or subtracting them, and the different words and how they can be written that way, now is a great time to use this notebook and use the examples that are in your book to go through and start working on those homework problems, and let me know whenever you get stuck.